Geometry Standard 9. We're still analyzing transformations. We're going to switch transformations to talk about reflections. So we're going to do the same thing we did with translation, except for our transformation this time is reflection. So our learning target is, I can verify and explain how an image remains congruent. Notice we're still talking about congruency after the pre-image has been transformed by a reflection and can be described as the changes that occur to the x and y coordinates of a figure after that reflection, which is known as coordinate notation. So we'll get started right away with some vocab that we'll be using. And you've probably heard these words before because I've talked about them in the last couple of videos. So a reflection flips a figure over a line of reflection in order to create a mirror image. So flips, or you think of it as a mirror, and then we're going to go over, and we're only going to go over the x-axis and the y-axis. When you get into high school and do more geometry and transformation, you'll reflect over different lines, different vertical and horizontal lines, but for 8th grade math, we're just going to focus on the x-axis and the y-axis. Each reflection point of the figure should be the same distance from the line of reflection. So I'll talk about that as we reflect. Highlight and identify the lines of reflection. So this is what I was just talking about. So if we look at the smiley face with the tongue sticking out, it's been flipped over this line. Okay, so if you notice, they're the same distance from each other. They're a mirror image. So if you think about like a body of water, you're standing here and you look into the water, it's going to be a mirror image. So this reflection line, you'll hear me call it a lot. What line of reflection are we looking at? And that is the x-axis. If you look at this smiley face, you'll notice it's reflected, what we call it, horizontally. So it's reflected from this side, I'll put a nose on him, over to this side. So that is over the y-axis. So let's get started right away on reflection. So let's reflect the figure shown over the y-axis and record the coordinates of the pre-image and image. So I always just like to highlight which one that I'm actually reflecting over. So it says reflect over the y-axis. So we're going to reflect this. It's like a mirror image, and if you go back to that definition, it's going to be the same distance away from the reflection line. So if you look at it right here, W, we're going to look at the point W here. Notice point W is this 2 lines or 2 spaces away from the line of reflection. So W prime is going to be the same distance away. So we're going to call that W prime. Y, same thing, 2 boxes away from the line of reflection. So Y prime will be the same. And then X, okay, notice it keeps on that same line, so it's going to still be on Y is 4. We can count 1, 2, 3, 4, 5, 6, 7, or I could just look down here and notice it was on the 7th. So I'm going to flip over that same amount, 1, 2, 3, 4, 5, 6, and 7. So this would be X prime. And get your straight edge out so it looks a lot better, so you can actually tell they're congruent. And there is your reflection over the y-axis. We're going to write down the points. So we'll go W, X, and Y. W is at 2 and 6. And then W prime. Now start to notice some patterns here because it's going to ask about these ordered pairs. W prime now is at -2, 6. X is at 7, 4. X prime is at -7, 4. Y is at 2 and 2. And looking for Y prime is now at -2, 2. So if we look at this really quickly, notice that the X values, which is 2, 7, and 2, in the pre-image, changed to -2, -7, -2. So what do I notice? I notice that the x values changed to their opposites. So in this case, they were all positive. So notice they all changed into negative because that would be the opposite. So 2, the opposite of 2 is -2. The opposite of 7 is -7. The opposite of 2 is -2. Look at the y values. So 6, 4, 2, 6, 4, 2. No difference at all. So the y values stayed the same. Okay, remember, this is over the y-axis. So start to learn these patterns. How do we represent this algebraically? Well, we're going to start with our x comma y, because that's our original. Actually, I'm going to put it over here first. So x comma y, those are our pre-image, and it changed to, the x's changed to their opposite, so we're going to use a negative to prove opposite, and then the y's stayed alone. So again, the x's changed to the opposite, in this case was negative, and the y's remain the same. Okay, next one, we're going to reflect over the x-axis, so I'm just going to highlight it so it's easier to see. On my actual paper, I highlight it with highlighter. So we're going to reflect each one of these points. So D is 2 away, straight across will be D prime. F, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And actually, I'd probably look at, like, F is at -7, so it's going to come up here at 7. But you can also count. And then E is 1, 2, 3, 4, 5, 6, 7 away. So E prime will be 1, 2, 3, 4, 5, 6, 7 away. E prime. Then take your straight edge. I'll try to do my best here. And there is your reflection over the x-axis. Okay, so it's like a mirror image. In elementary, you probably called it symmetry, where you would fold on that line. It'd be the same thing on both sides. We're going to put the coordinate points down here. So we'll do D, E, E, F, and then D prime, E prime, and F prime. So D, the original D, the pre-image was at 2, -2. And the image is at 2 and 2. E is at 7 and -7. And the image, the prime, is at 7, 7. F is at 2 and 7. I'm sorry, I looked at the wrong one. F is at 2 and -7. And then F prime, this one's at 2, 7. So what do we notice? Well, we notice, let's look at the x's here. 2, 7, 2, 2, 7, 2. The x values did not change or remained the same. And we're going to look at the y values. So in this case, we have -2, -7, -7, 2, 7, 7. So notice, again, they're the opposite. They're not the same, they're the opposite. So the y values changed to their opposite values. Okay, so again, let's look at the ordered pair. So here's our original. So we already noticed the x's don't change. We're just going to write x, because x is going to be the same every time. Now the y, you got to be careful here, because some of you think of this. So if you had -2 and you're trying to get to 2, well, it's going to be the opposite. So that negative sign really means opposite in this case. So for example, so we have -2 is our original right here. And then if we're going to change it to the opposite, so if I follow the rules, so if this is my y, and then I'm going to put a -2, well, 2 negatives in a row make a positive. So that's how it turns into that opposite. So don't think of this as a negative at y, it's the opposite of y. So again, the rule was, here's your x, y, and it changes to X stays the same, and Y changes to its opposite. Okay, let's reflect again, this time over the y-axis. So here's my y-axis. Just do a quick line if you want to. R, 2 away, R prime. P is at 7. I'm going to do this a little faster since that's 7 away from 0. And then this will also be 7 away to 0 crossed if I flip it. And Q is at 5, it looks like. So U prime will also be at 5. When you draw these, just make sure that they are congruent in size. So when we went over the y, what happened to each of the coordinates? So let's just do an example. Let's do Q. So Q was at -5 and 7. So right here, -5 and 7. It changed to, when I flipped it over, so Q prime, changed to 5 and 7. So looking at the x values changed to their opposites. So x values became opposite values. Whew, sorry about that writing. And then the y's, 7, 7, remain the same. And then, so we have that one done. So again, over the y values remain the same, but the x values actually become the opposite. Because if you think of it, if you're going over the y, you're going horizontally. They're still in the same y. Notice they're still on 2, these 2 points, but it's the x's. So it went from -2 over here to a +2. So over the y, the x's change. Let's do the same thing here. Let's go over the x. So it says reflect your new triangle. So my P prime, Q prime, R prime over the x. We're going to go this way. So R was here at 2, 2. So R prime will be 2 away down here. Actually, we're going to call it double prime, which that means is that we've moved it twice. R, 2 away, R double prime. Q is 7 away, so we're going to put 7 away down here. So we're going to call that Q double prime. That just means 2 little slashes. Get your straight edge, draw the nice triangle, look at it. They look congruent. So look again, it says what is happening to the coordinates. So if we look at Q prime, which is the point we had there, 5, 7, and it changed to, we're going to put double prime there because we've moved it twice, changed down here to 5, -7. So what happened to the x's? Absolutely nothing. So this time when you go over the x-axis, the x values remain the same, while the y values, let's check those out. So 7 to -7 become their opposite values. Okay, so a couple questions here. Bella thinks that the transformation below is a translation. Is she correct? Well, first of all, if it's a translation, they're going to stay congruent, and they are. But if it's a translation, when they slid this over here, this H would be here. So this would be H prime, this would be I prime, this would be G prime, and this would be J prime. But that's not the case. So I can tell it's not a slide. The other way I could tell is if you look at the origin of the vertices. If we go H to I to J, J to G, G to H, and then we look at the other one, going the same way. So we went H to I first. So H prime to I prime to J prime to G prime, and G prime to H prime. Notice the first time we're going clockwise around, now we're going counterclockwise around. So the answer is no. This is not a translation, 2 reasons. If you would have slid it over, the H corresponds with, should have been H prime here, so the coordinate points or the corresponding points don't match up. And then also the orientation of the vertices are not the same. Okay, so this is a reflection. I'm just going to talk through this, so just kind of listen because it'd be hard for me to write all that. Plus, it takes a long time. Similarities. So we're going to compare and contrast translations, which we just learned about, and our new reflections. Well, both of them, let's put keywords in here, make congruent images. So it doesn't matter if we slide them, known as the translation, or reflect them, they're going to remain congruent images. So when you get done, one quick idea is look at them. If they're not congruent, you did something wrong. Some differences between them, well, just the movement. A translation is a slide. A reflection is a flip. So the movement themselves are totally different. You either slide across like a conveyor belt or you flip it over like a pancake. The other reason, we could talk about those orientations. If you translate, so if this would have been H prime or H prime, I prime, G prime, and J prime, the orientation would have been the same. H to I prime to J prime, G prime to, J prime to G prime, and G prime to H prime. Notice that you're still going clockwise, we're still going clockwise. So when it's a slide, those orientations stay the same. When it's a flip, I already just talked about that, then the orientations of the vertices actually reverse. They go into counterclockwise. Next question. So what have we learned? So if we can just do the points without actually reflecting it. So if we call this our XY, so our original points, and we go over the x-axis. So if we go back to our notes, every time I go over the x-axis, the x stays the same. Again, we're going over the x, and the y turn into their opposite. So x stays the same. We'll just do all our quick x's here. And then the y's turn to their opposite, not negative, to the opposite. So the opposite of 8 is negative 8. The opposite of 1 is negative 1. The opposite of 9 is, opposite of negative 9 is 9. The opposite of negative 11 is 11. And the opposite of 12 is negative 12. This time we're going to go over the y. So start with the original, and we're going to go over the y, which means the x's change to their opposite, and now the y's stay the same. So the opposite of 6 is negative 6. The opposite of opposite of negative 5 is 5. The opposite of 10 is negative 10. The opposite of negative 4 is 4. And the opposite of 7 is negative 7. And then the y's stay the same. So we can just go ahead and put the same y. 1, negative 9, negative 11, and 12. Okay, so the important part here, put a star by it, smiley face, something. What did we just learn? Well, we learned, and I'm just going to put the rule here because it's easier mathematically to look at. If you reflect over the x-axis, so those are your normal x, y coordinates. When you go over the x-axis, the x values stay the same, but the y values change to their opposites. And when you go over the y-axis, so we'll start with the normal xy, the x values change to their opposite, and the y values stay the same. And the last little thing is we're just going to prove that we can reflect again. So we're going to reflect over the x-axis. You've got to be really careful which x you're flipping over. So over the x. So since this is, looks like 3 away. 1, 2, 3. We're going to go 3 away. Call that B prime. A is right here on 1. 9 away. So up here it's going to be 9 away. A prime. C is also 9 away. On the x is 9. So that's C prime. Take your straight edge. Connect them. And they should be the same shape. Mine's not bad. And then just a reminder, corresponding. So AB right here corresponds with A prime, B prime. Make sure you put your line segment. BC corresponds up here. Really down just a little bit. B prime, C prime, line segment. And then AC corresponds with A prime, C prime, line segment. And we'll do the same thing with the angles. Angle A here corresponds with angle A prime. Don't forget your symbols. B corresponds with B prime. And notice they keep being the same distance away. That's, it's a good reflection. It's the same distance away. And C here, we'll make with 3, 3 is corresponding with C. I hope this video was helpful for you, and have the most wonderful day.